What if hackers could poison your AI, teaching it lies, inserting hidden backdoors, and making it betray you without you ever noticing? Today, we'll explore data poisoning, how attackers can abuse training and fine-tuning pipelines, why OWASP lists it as a top risk, and most importantly, how you can defend your models. Data poisoning is a direct attack on the integrity of AI systems. When attackers manipulate training or fine-tuning data, the model learns the wrong patterns. OWASP highlights this as one of the top risks for LLMs. Poisoned data can make models biased, unreliable, or even embed hidden backdoors that only activate when triggered. And here's the problem. Today's AI models are trained on huge datasets, often scraped from the internet or supplied by third parties. That means a single poisoned source can affect millions of model outputs. In other words, this isn't just about code security. It's a supply chain risk. If you can't trust your training data, you can't trust the model. Let's make this simple. Data poisoning is when attackers mess with the training data. Imagine teaching a child with a school book where some answers are wrong on purpose. The child will learn the wrong things. Model poisoning is when attackers mess with the model itself. It's like sneaking into the child's brain and changing how they think, not just what they're taught. Both are dangerous. One poisons the lessons, the other poisons the learner. Data poisoning is more common in practice because datasets are easier to manipulate than model weights, especially in open ecosystems where anyone can contribute. So who could poison your AI? And where are the weak spots? Insiders who control data pipelines could deliberately slip in manipulated records. Third-party vendors might supply datasets or pre-process data that already contains poisoned samples. Community contributors in open datasets might sneak in malicious examples hidden among millions of normal ones. Even automated web scraping can be tricked if attackers plant poisoned content right before your scraper collects it. The weak points are everywhere. Pre-training corpora, fine-tuning datasets, embedding stores for retrieval-augmented generation, and even public model repositories. This is why OWASP treats data poisoning as both a technical and a supply chain security challenge. Let's make two poisoning techniques crystal clear. Split view poisoning is when an attacker ensures that your training pipeline sees poisoned data, but your monitoring or auditing tools only see the clean version. The result? You think everything looks fine, but the model is quietly being corrupted. The lesson is that auditing must always look at the exact same data the model trains on. Front-running poisoning is when the attacker times their move perfectly. Just before your scraper collects data, they inject poisoned content. The scraper grabs it, unaware, and the poisoned sample slides directly into your dataset. The lesson here is that freshness and provenance checks are critical when ingesting external data. Both are subtle, both are effective, and both underline how fragile AI supply chains can be. This isn't just theory. Let's connect it to reality. A poisoned dataset scraped from the web could bias a model's outputs on sensitive topics. A poisoned set of resumes in a recruitment AI could systematically prefer or reject certain candidates. A poisoned customer support dataset could make a chatbot reveal sensitive information when a hidden trigger phrase is used. In all these cases, the attacker doesn't break into your servers. They poison what your model learns, and once it's trained, the corruption becomes part of the model's DNA. So, how do you defend yourself? Here's a defensive playbook. Track dataset provenance and versioning. Vet external data and vendors, and require signatures and checksums. Run artifacts in isolated sandboxes before using them. Use anomaly detection to look for outliers, duplicates, or label inconsistencies. Guard against split view poisoning by making sure auditors see the same raw data as the model. Protect against front-running by checking timestamps, batching ingestion, and verifying freshness. Use robust training techniques like trimmed mean aggregation to reduce the effect of poisoned samples. Sign and verify models, especially when downloading from the community. Red team your ML pipelines by simulating poisoning in controlled settings. And finally, monitor outputs in production and keep humans in the loop for high-risk decisions. No single step is enough, but together, these measures can drastically reduce your exposure.